Okay, one of the first tricks here that we've seen like this, I think, find the indicated partial sum. Now you look at this and you say, oh, this is a fourth partial sum, but you're forgetting this down here. Okay, I have mentioned this in the past when we were talking about these some of the formulas that we've done. Now you look at this and you say, gosh, this looks like it's a geometric sequence, but most of our geometric sequences, this is n minus 1. Well, this is n minus 1 when this is 1. Okay, so if this was a 1 and this was n minus 1, that overall value would be 0. So when we make this an n, we have to make this a 0. It's really, that's if you want to use the shortcut to this. If you don't, take a look. What does this mean? We're going to plug this number in here, and we're going to stop when we plug in that number. Okay, so how many numbers are there in this sum? Right? Let's take a step back. How many numbers were in this sum? We plugged in 1, then 2, then 3, then 4, then 5. There are 5 terms in that sum. Right? This number is not saying there are 4 numbers in this sum. This number is saying stop after you plug in that number. Start with 0. Plug in 0, plug in 1, plug in 2, plug in 3, plug in 4. So this is actually a fifth partial sum. Okay? There's no trick to this. Okay? You can plug the 0 in. Then plug in the 1. Dot, dot, dot. And then your last term would be to plug in the 4. Now you recognize this is a geometric rule. Don't get me wrong. We are multiplying by 1/10 every time. If you want to use the formula, okay, and I'm going to give you these on a note sheet when you take the actual quiz, okay? But if you want to use this formula, you can. The first term in this sum is not what we get, and this is where it gets really weird, right? If you're comfortable doing this, just do it, because what I'm about to say may confuse you. I'm worried. The first term is the first term in this sum. The first term in this sum I get by plugging a 0 in, right? Which is 6. So if I put a 0 here, 1/10 to the 0 power is 1. 6 times 1 is 6. The common ratio we have is 1/10. How many terms are in this sum? It's not 4. We've already established. Because we start at 0 and end at 4, there's 5 terms in this sum. So you could use this formula if you wanted to, but you got to be careful with the numbers that you're choosing. This is the first term. It's not what we get when we plug in 1. It's what we get when we plug in 0, because that's the first term in this specific sum. Okay? Tricky. Nothing wrong with this. Nothing wrong with using that model and just making sure you have the right number of terms in your sum.